Hello, and welcome to the lab where you will use graph analytics to make movie recommendations for customers. In this lab, you will use graph analytics to make movie recommendations for customers who have been identified as churners in the previous labs. So let me start with an overview of graphs. So modeling your data as a graph enables you to make explicit the relationships between data entities. And this allows you to apply graph algorithms to your data. For example, you can identify communities within your data. You can identify important vertices, that is vertices which are highly connected. You can find paths in your data and so on. And when you represent your data as a graph, you can look for graph patterns and you can query your data to identify these patterns. And this makes the ability to identify patterns and the ability to do analytics makes the graph data model really powerful. And you can model almost any data as a graph. In the example on the left, you have bank accounts, which can become vertices in your graph, and any relationship between them can become an edge. So when an account transfers money to another account, that's a relationship, and that can be an edge, that's a cash transfer edge. On the right, you have customers and products as two different types of vertices. And when a customer buys a product, that's a relationship between two vertices, and that becomes an edge. So any logical connection between data entities can become an edge in your graph. And in the property graph data model, edges and vertices can have properties associated with them. And you can model your graph from any data set right in your Oracle database. And after you model your data as a graph, you can use a graph query language to find paths like variable length paths, fixed length paths. I want to see whether there is a path of length 4 between these two vertices. Or you can find cycles. Are there 3-hop cycles, 4-hop cycles, and so on. Or you can look for specific patterns that you can represent in your graph query language. And in the algorithms, you have a variety of algorithms that you can apply to your graph to detect communities, to find important nodes, for example, using the PageRank algorithm. You can do graph machine learning on your graph. You can analyze the structures in your graph and so on. And customers are using this to build a variety of interesting applications. In this example from the financial services industry, they use path analysis to identify whether cash transfers between two accounts are going through a lot of intermediate accounts. So that's something they would like to flag and investigate further. In network management, you can use graphs to do what-if analysis, like what happens if a node goes down. And also, there are some interesting work being done around using graphs to detect malicious traffic. So rather than looking at IP addresses and IP packets as individual entities, you can look at how the IP packets are flowing between nodes and create a graph from that and use that to detect similar patterns. In manufacturing, graphs are used to model bill of materials, so we can do what-if analysis, what happens if the design of a component changes, which are the other components that would be affected, and so on. And you can also use graphs to make product recommendations, which is what you will be doing in this lab. So a summary of the graph features is here. And one key feature is that you can create a graph from database tables. So your business data is probably in database tables, and you can create a graph right there. You don't have to move your data to a specialized database just for creating a graph. And the Oracle Graph feature includes an in-memory graph server for highly scalable graph analytics and graph querying. It includes a property graph query language, which is a SQL-like language for querying graphs. And by SQL-like, I mean you have the select clause, the from clause, the where clause, the count star, and so on. And in addition, you have the ability to specify a graph pattern, the ability to specify vertices, edges, how they're connected to each other, and so on. Oracle Graph also includes over 60 pre-built graph algorithms for detecting communities, identifying important nodes, doing path analysis, and more that can be invoked using a Java or Python API. And all of this is built on Oracle infrastructure. And when you're using Autonomous Database, you can use the Graph Studio feature to get a fully managed service that includes all of these features. And the Graph Studio feature of Autonomous Database is fully managed and it automates many of the graph creation processes. For example, you can say that these are the tables I want to use in a graph, and then it'll create the graph for you, and you'll see an example of that in the lab. And the Graph Studio can be invoked right from the Autonomous Database console, and you can get started in minutes to model your graph and do interesting analytics and queries on your graph. So it's very, very easy to get started with using graphs when you use the Graph Studio feature in Autonomous Database. So that's what you'll be using in this workshop, the Graph Studio feature of Autonomous Database, but you also have graphs available in other deployment options. For example, if you have a user-managed database on premises, you can use the Oracle Graph feature there as well. So now coming to this lab, there are several different tables that you've been using as part of this workshop. In this lab, you'll be using three tables: the customer table, the customer sales table, and the movie table. And the customer sales table, of course, tells you which customers have rented which movies, and that becomes the edge table. So you have customers a vertex table, movies a vertex table, and cost sales is the edge table. And we'll actually be using a subset or a sampling of data from these tables to create a graph. And then you will use the whom to follow algorithm, one of the over 60 pre-built algorithms that are available. And you use that for a particular customer who has been identified as a potential churner. And for that customer, you identify the community that they belong to based on other customers who have similar movie watching habits. And then based on this other community, you make a recommendation for this customer that the customer will probably like but has not seen yet. So it's a simple bipartite graph with customers, movies, and customer sales representing the edges. So in this workshop, as in any application using graphs, you would create a graph, you query a graph, you analyze a graph, and then you visualize a graph. So these are the typical operations, and I hope you enjoy doing them in this lab.